Guys, so we are going to start on 3.13 from our AP Pre-Calculus CED. That here is going to be talking about polar coordinate system, okay? So polar coordinate system is a little bit different than what you're used to at this point in time. You're used to rectangular points, or also known as Cartesian coordinate points. So instead now we're going to be using our polar coordinate system. So instead of using an X and a Y, we're going to use it set up as R and theta, okay? R is a directed distance from the pole to the point. Again, it is a directed distance from the pole to the point. And theta is going to be the directed angle in standard position, and is measured as a standard angle in either degrees or radians. So what this is just saying here is that with my angle, the angle itself is going to be in standard position for what we're known to be doing, everything in our unit circle, and it's going to have a specific distance from the center, okay? So that's what we have right here. The point in the center, also known as your origin in rectangular, meaning that on your XY coordinate grid, the very center 0, 0 is your origin. Instead, on a polar axis, that's called the pole, okay? And that's going to be this little spot right here in the middle. That is the pole, okay? The positive x-axis, so right here, this positive x-axis, that is called our polar axis, okay? So it's no longer an x-axis when we're doing polars. Instead, it's called a polar axis. And that's whenever we were doing things on our unit circle. We started from that positive x and we would go counterclockwise around. For polars, we're going to do the exact same thing. It says that if r is positive, then the point P lies on the terminal side of theta. If r is negative, then P lies on the opposite side of the terminal side. What in the world does that even mean? So what that's saying is right here, if this is my point, 2 pi over 6. I find pi over 6, my r is positive, because remember this goes in r theta, right? So r is that first number, the 2 is positive, and so it's located where that angle pi over 6 is. I know this isn't labeled with the angles, it's okay. When I come over here, this is the same, except it's negative 2 pi over 6. So it's in the same kind of place as that pi over 6 that was over here. It's just on the opposite side. So instead, it's actually where negative, or not negative, it's where positive 7 pi over 6 would be. It also could be negative 5 pi over 6, but, you know, we're about to do something with that, okay? All right, so let's go ahead and graph each one of these coordinates. So if I have 2 and pi over 3, the first thing that I want to do is I want to locate the angle measure, and then I apply what the r says. So that's whether or not it's going to be on the opposite side or if it's on the same side. So if I locate pi over 3, that's going to be right here, correct? And so from the pole, I go out 2 rings. So each one of these rings represents 1 on the r. So this would be 1, and then this one here would be 2. So there's my 2 at pi over 3. Okay, so there's A. Now, in order to do B, again, I find the angle, and then I go ahead and apply what the r says. So negative 3 pi over 4. Remember, negative angles go from the polar axis, and they're going to go clockwise around instead of counterclockwise. So the same distance that we went to get to 3 pi over 4 from here, so if we went here, we would go this same distance that we just did this, except we're going to go the opposite way. So instead of going counterclockwise, I'm going to go that same distance, and I'm going to go right here to this 5 pi over 4, okay? So that's what I'm looking at. This is the same as negative 3 pi over 4. They're coterminal with each other. So if you don't know where you're at and find things like that, if you're given a negative angle and you want to know where a positive one would be between 0 and 2 pi that you're comfortable with, remember, it's just a coterminal angle, so all you would do is add 2 pi. That way you can go ahead and get what you need. So I'm at negative 3 pi over 4, which is right here, and it gives me an r of 4. So from my center, I'm going to go out 1, 2, 3, 4. And there's my point B. Okay. Now, in order to do C, that's at pi over 3, but it's negative 2. So it's in the same straight line as this pi over 3 right here where A was, except it's not on pi over 3 over here. So if you notice, A and C are the same thing. I have 2 pi over 3, and this is negative 2 pi over 3. So they're not going to end up in the same place. They're on the same angle, but this is saying I'm going the opposite direction. So I'm going to go 1, 2 this way, okay? They're supplementary. They make up our 180 degrees or pi, okay? So if I take that pi over 3 and I add pi to it, I end up over here at 4 pi over 3. So here's C. And then D is at 3, and that should actually be a pi. I'll go ahead and just kind of write it in there. So is that 3, 11 pi over 3. Well, 11 pi over 3 is not between 0 and 2 pi. That's okay. I would just do 11 pi over 3, and I'm going to subtract 2 pi, so 6 pi over 3. If I subtract that, I get 5 pi over 3. And so that's where it's at. So here is 5 pi over 3. That's the same as 11 pi over 3. They are coterminal angles. So I found where 11 pi over 3 is, and I'm going to go out from the center 3 rings. So I'm going to go 1, 2, 3. And there's D. Okay? That is how you're going to graph these. So like I said, always find the angle, and then from there you're determining if it's negative or positive for your R, to whether or not you're going to be going on the same ray as your angle, or if I'm going to be going on the opposite side of that pole. Okay, now polar coordinates are not unique. So what that means is just like what we just discovered here, well, I shouldn't say discovered, but what we just applied here, 11 pi over 3 and 5 pi over 3 are exactly the same thing, right? Or 5 pi over 4 and negative 3 pi over 4 are also the same thing, right? I have an infinite set of ways that I can say the exact same polar coordinates, okay? What we're going to try and do is we're going to limit it so that it's between negative 2 pi and 2 pi. And so you're going to have 4 ways to state the same point. They're each going to have a positive r. I shouldn't say each. We're going to have 2 positive r's and 2 negative r's. 2 positive thetas, 2 negative thetas. So let's talk about how we find those, okay? So point A was 2 and pi over 3. All of the ways that I can list those coordinate points are going to be like this. R theta, R negative theta, negative R positive theta, negative R negative theta. So like I said, we're going to have 2 negative R's and 2 negative thetas, 2 positive R's and 2 positive thetas. So in this case right here, I've got 2 and pi over 3. That's my way to state it this way. Now, if I can do this another way as having a positive R but a negative theta. So let's look. If I came up here and I'm at pi over 3, I need to give a negative angle measure. So if I'm right here and I need a negative angle measure, couldn't I just subtract 2 pi from pi over 3 and that's going to get me my negative one? Sure enough, that's exactly what I can do. So let's do that. So if I do pi over 3 and I subtract 2 pi, now remember if I have 2 pi and I needed to have a denominator of 3, that's the same thing as doing 6 pi over 3, right? So that's what I'm going to do here so that I have my common denominator. Pi minus 6 pi, well, that's going to get me negative 5 pi over 3. And that's what I'm going to have right here for the r. So then that's going to be 2 at negative 5 pi over 3. Okay. Now I'm going to find my negative r and my theta. Okay. So if I do this with a negative r, that means instead that I'm going to be over here along this line for my 4 pi over 3, okay? So let's go ahead and try that one. Well, I just said it right there. 4 pi over 3 is going to be the opposite side, and that's a positive angle. So that's what I'm going to put. I'm going to say that it's at -2, but 4 pi over 3. That way, if I was to plot this, I would go to 4 pi over 3, for example. I would come right over here to 4 pi over 3. And I go, oh, it says -2, so it's on the opposite side right here. Okay? And then the last way to do it is with a -r and a negative theta. So that means now instead I have to figure out what would the angle measure be if I went this way and stopped here. Okay? So an easier way to do that is to take your reference angle of what you would have right there. And, well, nah, we're not going to do that. I think that would complicate it a bit more. So instead, what we're going to just do is we're going to kind of think about it here is if I'm here at 0 and I was to go this way, that's an equivalent distance of going 2 pi over 3. So that's -2 pi over 3, okay? So here I'm going to have -2, -2 pi over 3. And that's how I'm going to get my different measurements for each one of these, okay? All right, let's try our point B, okay? So point B was given to me, and that one was given to me as a 4 -3 pi over 4. So I've got 4 -3 pi over 4, okay? And I've got to rewrite this 3 other ways. Here we go. We've got 4 and we're at -3 pi over 4. So in order to get it to both be positive, I can take that -3 pi over 4 and just add 2 pi. And again, it's really helpful to have a visual here. So again, if I'm right here at B, all I want to do is take this angle, and it's negative, so I'm going to go the other way around, a full circle. That's 2 pi, and that's going to get me my positive value, which would be right here at 5 pi over 4, okay? And so that's what we're going to go ahead and do. That one would right here would be at 4 and 5 pi over 4, okay? Now we need to do it with a positive angle and a -r, okay? So if I did that over here. So if we were here at 5 pi over 4, the opposite side is going to be pi over 4, okay? And so that's the opposite of my straight angle, okay? And so that's going to be the one that I'm going to use with a -r. So here I would have -4 pi over 4, okay? My last one is a -r and a negative angle. So that means that I'm going right here from this pi over 4, and I'm going to go and have a negative value. So if I'm here, all I need to do is go the opposite direction, but negative. So that means instead of going right here to get that, I'm going to do a almost full circle and go this way from where I started, okay? And that's the same distance as 7 pi over 4, it's just negative, okay? So now I'm going to have -4 and -7 pi over 4. And that's how I'm going to list all 4 of the possible coordinates that I could have between -2 pi and 2 pi. Now, how would I list all polar coordinates? So I'm going to take the ones that have my positive angle measures. I'm going to take those 2 right here. And all I'm going to do is just add 2 pi k. So I would have 4, and what was it? It was 4 and 5 pi over 4. I did not write that properly. 4 and 5 pi over 4 plus 2 pi k. And then I'm also going to have -4, and I'm going to use my other positive angle here, which was pi over 4, okay? and that would be pi over 4 plus 2 pi k. And this is where k is an integer. Okay? So this is how you're going to be able to plot polar coordinates, and this is how you know all of the different ways to write the same coordinate, if you will. Okay? I'll make another video for the rest of this in just a second.